Hello everyone, my name is Márton Braun. I work at JetBrains as a developer advocate, and today I want to talk to you about going multi-platform with your Android app. So taking an existing Android app and migrating it over to be a multi-platform app, for example, to also target iOS or desktop or web. We'll get to it. This is going to be a multi-step process. So first we're going to talk a bit about strategy, how you can even approach a migration like this. Then we'll see how we can modernize an existing Android app to make sure that we're using the latest and greatest, all the best practices, because doing that first makes it easier to then take the jump to multi-platform. Then we'll do everything we can without actually going multi-platform to prepare for that, to minimize the one-time change that we'll have to do. And then we'll actually start adding more platforms so that we can run our code on multiple different platforms. So, starting with the strategy then. Now, the major point here that I want to make is that all of this can be done incrementally, and I would recommend doing this incrementally. You probably don't want to stop the universe to do that. You probably don't want to be the person who opens that PR. If you have teams working on features and like a busy repo, you obviously can't do things like this all at the same time. So, incremental is going to be the name of the game here. Now, as a general approach, usually people approach KMP migrations with a bottom-up migration, as in they start with the lower layers of the app. For example, they take the data layer of an Android application, migrate that to KMP, and then start sharing it across their Android and iOS apps. The exact layers I've written here don't matter, but whatever layers you have, it's usually the data, the core layers, things like that, that's easiest to migrate first. And then you can obviously keep going depending on how much of that code you want to share. So if you want to share more and more, maybe presentation logic, maybe 100% of your stack, including the UI and all of those things, then you can also do that over time. Now, one way that people tend to start with KMP is kind of a quick start approach. So for this, we're going to zoom in here and look at a specific application where, let's say that we have the Android application module at the top, and then it's modularized into a bunch of Android library modules beneath that for features and utilities and whatever it might be. So one thing that people often do is to start with a completely new module for doing KMP. So you put some code there. It can be like one function, one class at the start, and then you can immediately start shipping that to both platforms, depend on it with the Android app and depend on it with the iOS app, something like this. And then, of course, once you have this module, you can grow it over time. You can keep adding more functionality, more and more code that's shared between the platforms. You can take existing code that's in somewhere in your Android app. You can move those things over into the multi-platform module, and maybe eventually you can even eliminate some of your existing Android modules because the multi-platform part has consumed all of them. Now, you can do all kinds of interesting things in this setup. For example, I want to mention that you can have the Android libraries that you still have remaining depend on that multi-platform code, of course, for the Android part of the implementation. And you can also do this the other way around. So if the shared code needs to use something from the existing Android implementation, it can also do that. But of course, that will only work for the Android part. So if you also need that kind of feature for iOS, you'll have to implement that separately somehow. But it's worth knowing that these kinds of edges in the graph are possible. Over time, once you have grown this module large enough, of course, you can also modularize it the exact same way as we've been doing with Android libraries, so you can start having multiple KMP libraries that you work with. So that's kind of the quick start approach, but there are actually things here that might not be as trivial as they seemed on this slide, right? So obviously the great thing is that you can start shipping almost immediately. You don't really have to be concerned with legacy things in your app. You can just have this fresh module where everything's great and you start shipping that. But as you're, for example, moving files over from Android modules to KMP ones, there might be things that break because, well, they depend on Android APIs, they depend on libraries that are Android only, so you might have to do a bunch of migration work as you're doing this move code over sort of operation. As you do this, you might also end up in a situation where you have an Android part of your code base and a KMP part of your code base, and everything that you've moved over might start using new libraries for different aspects of your app. So maybe you switched from retrofit to Ktor, or from Dagger to Coin, or something like that. And while you can interop between a lot of these things, it's probably not a great time to work in a code base where the application is split in half across a bunch of different axes like this. So this kind of fragmentation is something that you probably want to avoid, certainly in the long term. And then if you do this, where you just create new modules and then occasionally drop existing ones, this also means that you're making a bunch of structural changes in your project. So if you have a lot of modules, if a lot of people are editing code here, this can lead to unexpected changes if you don't synchronize with everyone else as you're moving modules around. So that can also cause all kinds of issues. So let's take a look at another approach you can take. Do more of an in-place migration without trying to ship as quickly as before. So one thing you could do for a start is you could set the scope of modules within your existing Android code that you want to migrate. Let's say it's all of these libraries, and maybe this one here is something like a widget or something that you know that you're never going to migrate to KMP. Now, you probably don't want to do all of this work before you ship something to iOS, of course, because migrating all of this together could take some time. So it might be worth also setting some initial scope of functionality, which is like isolated, that you can start with. And once that's migrated to KMP, it actually makes sense to start shipping to, let's say, iOS as well. So once you have these modules figured out, you can kind of lay out an overview like this of the entire migration, where we have the modules on the vertical axis and all the migration steps on the horizontal one. So that gives us all of these little units of work that we need to do, all of the migration steps in all of the modules, right? And the question here is what order to try to tackle all of these steps in, all of these units of work in. And one thing you could do is you could go module by module. So if you really want to complete that initial scope, right, maybe you want to try migrating the first module, doing all the migration steps, making that KMP. And then you do the second module, make all of that KMP, go through all the steps, and then you can ship this. But again, there are things that aren't so easy in practice. So first of all, this introduces the exact kind of fragmentation that I've described earlier, where these modules might be now on a very different stack than the rest of your application. And there are also things that are very hard to do in isolation. For example, if one of these migration steps was a version bump of a library and then adjusting calls to the library to new changes, it's quite hard to do that on just a couple of modules and not your entire app, because a lot of versioning things tend to be global within the app. So another thing you could do is to first focus on those tasks that you have to or want to do for all of the modules at the same time, because again, avoiding fragmentation, or it's just an inherently global change in the project. So you could prioritize those steps first, complete them across all of your modules. Let's say it's, again, like a version change, a library migration, something like that. And then you could double down on that initial scope, go through all of the remaining steps, and start shipping it. So you kind of have a more balanced code base here the entire time. And then, of course, over time, you could go through all of the other modules as well and expand how much code sharing you're doing. But you have a project that's decently consistent. And I mean, as you can probably tell, this is a balancing act across these axes. So you can go really hard on single modules, or you can, if you have all the time in the world, you can just go step by step and migrate the entire app, and one day the entire thing becomes KMP all at once. But the reality is somewhere in between, probably. Now, a couple of years ago, Christina Lee gave a great talk at Kotlin Conf about how Pinterest tried to migrate to Compose, or have migrated to Compose in a bunch of things. And one of the takeaways in that talk was not to try doing everything at the same time. So they were doing a Compose migration, but that had a bunch of other requirements. They also had to move to coroutines. They have to move to unidirectional data flows in the app. So while they were just migrating to Compose, they were actually running 3 or 4 or who knows how many migrations in parallel, right? So pace yourself, and I really recommend trying to do the foundational work first and then move on one by one, because otherwise making this many changes at the same time can be hard, both on the code base, which we already discussed, but also on the people who have to work in the code base, because everyone has to learn everything new at the same time. So in the spirit of that and incremental migration, I'm going to break everything down into as many steps as possible here. And then if some of these changes are very small and you're actually doing these migrations, of course, you can always combine them, but I'll try to show you the smallest possible units that are possible. So let's start with modernizing our apps then, taking an existing Android app and bringing it up to modern standards. If you're lucky, you can ignore this section because you have a wonderful app with no legacy, but maybe not. So first things first, we're going to start with easy things. So if you want to use Kotlin Multiplatform, your code will have to be in Kotlin. So if you still have things that are in Java that you want to migrate, you should migrate them to Kotlin. Obviously, we have docs on this. We have a converter in IntelliJ, for example, and you can use all kinds of AI tools, which are pretty decent at this. And we also, of course, have Kotlin agent skills, which you can take a look at. As a next step, I would recommend migrating your build configurations. If they are still in Groovy, you probably want to move them to the Kotlin DSL because, well, it should be possible to do everything KMP in Groovy. You won't really find any samples or snippets that use Groovy anymore for this, so it's a much easier time if you move over to Kotlin there. A similar migration, if you are using capt for annotation processing, so the Java-based legacy compatibility thing to generate code, you should move over to using KSP instead, which is a Kotlin-first solution. It's much faster, and it just knows Kotlin a lot better, so it can do safer things in the generated code. Luckily, again, this is something that's extensively documented. There's a beautiful migration page in the Android developer docs, so you can follow that. And the good news is that generally, most libraries that are out there have been ready for KSP for several years now. If you have something in-house that does code generation with annotation processors, maybe you'll need to migrate that. Then, while we're at dependencies, it's a great time to update everything to latest, because there are entire classes of problems and bugs and issues that you won't run into if you just start with fresh dependencies. So there's a lot of wasted time that you can skip by updating dependencies first and then approaching the KMP migration. These things, of course, love to depend on each other, like AGP requiring Gradle versions and so on and so on. So I gave you a couple links here, which are also going to be at the end of the talk to help you with the compatibility between all of these things. Then, a great migration to do up next is to adopt coroutines, because if you're using things that are asynchronous libraries that are Java only, obviously that's not going to work in KMP. And KMP in general is very coroutines first. If you want to use Compose Multiplatform, Compose is also very coroutine friendly, so it also plays really nicely. And yeah, essentially, if you're using something like RX, or just Java threading APIs manually, those are things that you should migrate to coroutines so that they also work on other platforms. Then another migration to do, still kind of at the modernization step. Again, if you want to do UI sharing, the XML view system is not going to be available on other platforms, but Compose very much is. So if you want to share some UI, make sure that you migrate that to Jetpack Compose first. And the great part here is that you don't really have to worry about the multi-platform part when you do this, because Compose Multiplatform and Jetpack Compose are extremely close to each other. So layouts, animations, theming, navigation, including things like Navigation 3, all of these things are also available with Compose Multiplatform. So you can just migrate to Jetpack Compose, and things from there should transfer pretty neatly. And of course, I have to mention, this is also a migration that you can do incrementally, like basically all the others as well. Right, so now we have a theoretical modern Android app. So now we're going to start making steps that are transforming our app so that it's closer to where it will have to end up at for it to be multi-platform. So steps that aren't using KMP yet, but that shape our app in a way where it's going to be easier to move it to KMP. And this Jetpack Compose migration that we looked at as a modernization step is actually a good example of this, because a general step that we have to do is to move to multi-platform APIs, because if we're using something that's Java or Android only, we'll have to replace that with something that is platform independent. Now, when we use KMP, we're going to have a bunch of different source sets to place our code in. We're going to have the common main source set, which is used for all platforms, and then these auxiliary ones, which are only compiled to the given platform. And generally speaking, we'll of course want most of our code to be in that common main source set so that we get the benefits of writing that code once and sharing it across the different platforms. Now, in moving to multi-platform APIs, we'll probably have to do a bunch of library migrations. Here are just some examples of common replacements of typical Java or Android libraries and the corresponding multi-platform equivalent, or one equivalent or a couple of them. Again, there's a lot of choices here. There's thousands of KMP libraries, but these are some common things that you might encounter. So for example, if you've been using OKHTTP, you probably want to move to KTOR. Or there are a lot of things actually that are replaced by just the Kotlin standard library itself. So if you're working with collections, regular expressions, UUIDs, and you're using like Android or JDK or other utility libraries for it, maybe the Kotlin standard library actually already covers it and is multi-platform. And of course, there are cases where if you're already using the libraries on the right here, not just these ones, but here's a bunch of others as well. If you're already using these things in your Android app, because maybe you just liked Coin all along, or you're using Data Store and the Android team has just made that multi-platform in the meantime, or you've always used Coil for image loading in Compose, these things transfer very nicely because they are already multi-platform libraries. So you can probably keep most of your code intact and maybe just bump a version and change some initialization when you get to KMP. Of course, if you want to find more KMP libraries, you can always go to klibs.io, where we have all of them cataloged. And in general, I want to note that if you're still just in an Android app, but you are picking new dependencies because you need to put new features in there, for example, it's a great idea to, at this point, just err on the side of multi-platform. So if you need to pick between two new image loading libraries, maybe just pick one that's also KMP, because there's very little downside for using that for an Android app. And if you ever get to a point where you decide that that code should run on other platforms, you're just going to have a much easier time if you've made choices along the way that didn't lock you into a Java-only solution. Now, if you cannot find a library that does what you want to do, you can always use platform-specific APIs from KMP directly as well. And we have docs on this, we have videos on this, we have a bunch of content around it. But I want to show you just a couple common examples that might be useful. So one of the most well-known approach for this is the expect actual mechanism, where you can declare functions in the common main source set with no implementation, just their signatures. And then for each platform, you can have a different implementation. So you can have an actual function for Android. You can have another actual function with the same signature for iOS. And these can actually reach into platform-specific APIs, including the Android SDK, all of the iOS APIs, and so on. So this is one common pattern that you can use, which works really nicely for simple problems. And for more advanced cases, a really nice pattern to use is that you can also declare an interface in common code. Then you can create individual implementations for the various platforms. And that common code can, at some point, usually during app startup, when you're creating your DI graph and things like that, take the interface as a parameter. So each of these platforms can call that init function when they start up the app, pass in their own implementations, and then that can be called into from the common code. And the reason why this is really cool is because the expect actual functions have the same signature for every platform, whereas here you can just implement the interface with arbitrary logic. So these classes can be very different on different platforms. For example, a typical example is if the Android one has to depend on a context because it needs access to system resources, it can just take a context as a parameter, and the multi-platform code doesn't really have to know about this. All right, once this is done, you can prepare for AGP9. Who had to put hours into working with AGP9 recently? Not that many people. You're quite lucky. Okay. So AGP9 has certain requirements for KMP projects, which are better to prepare for in advance because, again, it minimizes the actual change when you go to KMP later on. Covered by a video, covered by a blog post, I'll give you just the highlights here. The biggest constraint in AGP9 is that if you're using either build flavors or variants of any kind or native builds in your Android libraries, then that library is not going to work as a KMP library because these things are no longer supported in KMP libraries for Android. So you can either move these things up, like into a higher up library or into the application module, or if that doesn't work in your case, you can introduce a new Android library which isolates whatever code is working with the variants or native builds, and then the original library that you have can depend on that just for its Android implementation. So this kind of isolation is worth doing before you go KMP, because you will be forced to move these features outside of the KMP modules. And then a very similar thing, which kind of comes with variants, is if you're using build config for anything, that's obviously an Android feature, so it's not going to work on other platforms, but there are alternatives such as these two plugins that you can pick up and use build config even on multi-platform. Speaking of multi-platform, we're finally here. We did all the preparation we can do. We did all the steps, all the transformations, all the refactorings, and obviously, this was already a journey with library migrations, which on their own can take a really long time potentially if you have a large code base and you really want to keep it consistent and you did all the modules at the same time. But now we're actually ready and we can start flipping some modules to be actual KMP libraries. Now we could do this in basically any order. So if we really wanted to, we could pick an arbitrary module in there in the middle and start with going KMP with that one. But of course, it's still easier to go by the leaf nodes and do a bottom-up enabling of KMP libraries. But the reason why this would also work is because the way that we're going to approach it is that we're going to flip our Android library to be a KMP library instead, but only for one platform, only for Android for a start. Because again, we're just minimizing the individual steps here. So to do that, we'll have to do these things. We're going to have to switch the actual plugin. We'll have to move our dependencies and sources around. And then, again, some AGP9 related changes that we'll need to tackle. And if we want to do UI sharing as well, then we'll have to, of course, enable Compose Multiplatform. We'll have to configure our previews so that they continue working after going multiplatform. And we'll have to move some resources around as well. So KMP plugin first. Previously, we had an Android library. We're now going to have a Kotlin Multiplatform library, and we also need to add an Android integration next to it. Then, for all of the build config we had, which was setting up our Android library before, that now becomes a target under the Kotlin block. So we just need to nest it under Kotlin now. And then when you do this, basically a bunch of things break. All of this doesn't work the same way when it's a KMP library. But it's not terribly hard to fix them up, and there's really good documentation for this part as well. So, for example, under default config, we were setting a min_sdk value. Well, KMP libraries don't have variants anymore, right? So there's no default config, but min_sdk still makes sense. So that can actually just move to the top level like this. Or we were setting compile options, which are for Java compilation, which we're probably not doing anymore in the KMP library, although you technically can, but we're not going to get lost in that. And so this we either just remove, or maybe we can just change the Kotlin JVM target to use Java 11 here. And then things like build features, most of them are unsupported in KMP libraries. Again, things like build config don't make sense anymore. And Compose, for example, just doesn't need to be enabled like this, so we can just remove that bit. Then I said we need to move dependencies around. So with an Android library, we have a top-level dependencies block where we list all of our dependencies. With a KMP library, these dependencies are under Kotlin source sets because we can add dependencies for common main, which is for all platforms, but we can also add dependencies for specific ones like in Android main. So for all of our existing dependencies, we have to figure out which ones are moving into which of these new dependencies blocks. And well, anything that works on all platforms should move under common main, while the rest of it, if you know that some dependency is definitely only going to be used on one platform, for example, then you can move that under Android main like this. Then we need to do basically the exact same thing with our sources. So instead of just having src main Kotlin, in a KMP library, you would have src common main Kotlin. So you can essentially just move all of your sources from there to here. And this is actually the point where you find out if you have done all of the migrations correctly previously. So if you still happen to be using something that's Java or Android specific, this is when your source code would break and where you could go back and retrace your steps and fix up your code. Then some fun AGP9 opt-ins. There are things that are enabled by default for Android libraries, but not enabled by default in KMP libraries. So if you need to use Android resources, or you're using either host or device tests, so that's unit and instrumented tests, then you'll also need to re-enable those manually. And then we get to the CMP part, which is basically just one more plugin. That part is easy enough. Then for all of the Compose dependencies, you'll want to switch them out for the multi-platform variants of them. So instead of the Android X Compose dependencies, you'll want to use the org JetBrains Compose dependencies. But everything like Foundation, UI, runtime, all of these dependencies are available the exact same way. The interesting part here is probably going to be versioning, because with Jetpack Compose, you're probably using a BOM to version your dependencies, which is not how we do it with Compose Multiplatform. So here you'll probably want to specify explicit versions. The good news is that most of them are just the exact same version as the CMP plugin itself, so you can just use that one reference across all of them. There are some outliers. For example, Material, Lifecycle, and Navigation have their own separate versioning schemes, but if you ever need to find these, you can find it on the GitHub release notes for each CMP version. You just scroll to the bottom, and all of those are listed down there. Then something really important if you're doing UI development is to keep your previews working, of course. So you can also just basically swap the two previous dependencies that you had for Android previews to work for the multi-platform versions. So there's a tooling dependency, which makes the IDE happy, and then there's the actual runtime dependency, which you need to pull in the preview annotation so that that resolves in your code. And after that, using previews, luckily, is the exact same at this point with multi-platform as it is with Android. So you can use the preview annotation, you can use built-in things like multi-previews, like preview light dark, and all of this works in common shared code as well, and uses the same Android tooling mechanisms in the IDE to render all of your previews. The last step with Compose Multiplatform is to migrate resources. So if you've been using things like drawables, strings, and so on, you'll need to move these over to use Compose Multiplatform resources instead of Android resources, because obviously Android resources are also, again, platform specific. So the way to do that would be to make sure that you have Android resource processing enabled, another fun HTTP9 change. Then you add the Compose resources library as a dependency, and optionally you can customize what is generated here. For example, by default, the accessor class that's created for you, just like the R class on Android, is called res when it comes to multi-platform resources. If you want to customize that, you can do that as well. And then another source folder transformation here. Instead of having a res folder under src main, there's now an src common main compose resources folder. So you can essentially move your resources over there. And most things work the same way with small caveats. You can read about those in the docs, but there's support for drawables, files, fonts, and string resources here. Okay, so with this, we created a KMP library, and it has only the Android platform enabled so far. And we can do this across our application. We can end up with this app, which is a KMP app which only targets Android, right? And eventually we want to add additional platforms. For example, you would probably want to start with iOS if you're coming from the mobile developer use case. And this time it will be important that you actually go from the bottom up through the leaf nodes, because to turn any given module here into an iOS library as well, all of its dependencies will also have to support iOS. So we can't make like a top module here an iOS module, because its dependencies wouldn't support that platform yet. So we'll start from the bottom, and we can go one by one and slowly add iOS. Actually, I misspoke earlier. So this is when you would realize that your code breaks. Because as long as you only have the Android platform, anything that is Android specific still works in common main. But once you start enabling additional platforms, then the compiler will force you to make sure that all of the code that you have in shared code actually works across all of your platforms. So this is where you would have to go back and fix things if you haven't migrated them to multi-platform correctly. And then, of course, there are other platforms beyond iOS. I want to emphasize that. JVM desktop and the web are also supported, both with WASM and JS. And there are great use cases for all of these. For example, JVM is relatively easy to get going if you're coming from an Android app. Obviously, even Java libraries still work. And it can be a really cool development platform because it's very fast to compile and run. And you also get Compose hot reload if you're doing UI development. All right, I want to address one last thing when it comes to using KMP, which is how things are packaged for iOS. So let's say that we have these beautiful KMP modules here, and we have, of course, the Android app still depending on like some of these, maybe those top two. It might make sense to you that the iOS app should work the same way, that you should just have a dependency from the iOS app into those topmost modules and work with that. The problem with this is that when you do this, these two subtrees would both produce an iOS framework, which would then be pulled into the iOS application. And these frameworks would duplicate any class that both of these have depended on. So for example, the Kotlin standard library and foundational things like that, or even your own code if these trees meet somewhere in the middle, would be duplicated in both of these packages, and these copies would be binary incompatible with each other. So this is like a really bad time that you should want to avoid. So the solution for this on iOS is to make sure that you only depend on one topmost KMP module, which we call an umbrella module because it encompasses like everything below it, right? I'm now realizing I should have drawn a larger umbrella. Anyway, so you want this kind of umbrella module. And the only difference here is that instead of just declaring the iOS platforms, you also add these couple lines that make sure that this module produces an iOS framework so that you can pull that into your iOS app. Now, once you do this, an interesting question is how your code is organized across repos. Now, for the Android code, it doesn't really matter if it depends on the umbrella module or just on any of these shared modules directly. All of this works arbitrarily across repos, through Maven. Anything you want to do works on Android. For iOS, it's a bit more interesting. If you're in the ideal setup, the easiest time is probably to have a monorepo with both of these apps, because then if you need to make changes to the KMP parts of your code, and those require changes on the iOS consuming side, you can make these at the same time. And these can be on the same PR, for example. Things get more difficult if these repos are separated, because now there's a publication step there, right? Now the umbrella module has to build that framework, you have to publish that somewhere, and the iOS repo has to pull that in. So if multiple teams made changes to multiple features in the KMP code, those features are going to land in the iOS app at the same time, which means that you probably have to adopt the iOS app to those new changes at the same time, which can lead to like weird conflicts and difficulties with organizing these sync points. Again, for the Android app, it doesn't really matter if it happens to be in the same repo. So that can also be in its own repo if you want, but that's just Maven, so it works arbitrarily. Now, one more thing that you could do here, which we haven't talked about too much in the past, but very much works, is you could actually move the umbrella module into the iOS repo, which makes it so that you can publish all of that KMP code as just Kotlin Multiplatform libraries, so not as iOS frameworks, just as klibs to like a Maven repo. And then that umbrella module in the iOS repo could independently pick every single version of those KMP libraries for itself. So you could, one by one, adopt new versions of those KMP features and then do all of those changes, for example, on a single PR within the iOS repo. So that's something to actually consider here. Okay, we went through a lot. I tried to be quick about it. I hope it felt quick. There are a lot of things you could go on to look at from here. We have all of these project configurations and umbrella ideas detailed on this first docs page. If you're looking for ideas on how to tackle this as a team, obviously I haven't talked about the team and people aspect of this that much. We also have a bunch of docs around that. If you're going to be doing KMP on iOS, I cannot recommend checking out Swift Export enough. Because it makes it much, much nicer to consume KMP code from the Swift side. And once again, The desktop platform can be a great development platform. So if you're doing UI sharing, then Compose Hot Reload can be very, very nice to use there. That's everything I wanted to cover today. All of the links throughout all of these slides are in this single one here at the end. Thank you so much for listening. And I guess we can do a couple questions. One question, thumbs up question. So we can do a couple questions if anyone has any. Otherwise, thank you.